Hey my dear data friends, it's Nicola from Data Mozart. Welcome to the new video where we will explore the new Direct Lake on OneLake feature just introduced by Microsoft. I like to think about this one as Direct Lake 2.0 version because it's a natural evolution of the existing Direct Lake that was introduced since the beginning of Microsoft Fabric. So what's the big deal with this new feature? I'll try to explore in the following next few minutes, and we will talk about the main differences and main advantages between the new Direct Lake on OneLake mode versus the existing Direct Lake mode, which is now called Direct Lake on SQL. I'm in the Power BI desktop, and as a first prerequisite to be able to use this new feature, because it's still in preview, you need to go to Options and Settings and then Options. And then let's go to Preview Features. You need to enable this feature called Create Semantic Models in Direct Lake Storage Mode from one or more Fabric artifacts. That's the new one. Also make sure to check this live edit of Power BI Semantic Models in Direct Lake mode if you want to leverage Power BI Desktop for live editing of the existing Direct Lake models that are already stored in the workspace. So these two settings are relevant for Direct Lake storage models. This one is specifically related to the new Direct Lake on OneLake storage mode. So this one is already checked on my side. So I'll bring or I connect to data that is stored in OneLake. I'll go to OneLake catalog on the top and then pick one of the lake houses that I have. For example, these fundamentals _ms _fabric. And then under connect, I'll click on the small down arrow. There are two options to choose from. So there are two flavors of Direct Lake right now. Connect to SQL endpoint, that's the old one, the existing one. This is the Direct Lake that we know since the introduction of Microsoft Fabric. And also there is the option, the new one, connect to OneLake, which allows us to connect directly to Delta tables stored in OneLake, bypassing the SQL Analytics endpoint of the lakehouse or warehouse. So I'll click this one, connect to OneLake, and then let's create a new model. I'll call this one Direct Lake on OneLake demo. I'll store it in the same workspace where my lakehouse is currently stored, but you can also change the workspace of the model. And let's bring some tables from Contoso sample database, customer date, product, and fact online sales. So I'll click OK and wait for Power BI to establish the connection to the lakehouse. Okay, so a few things to bear in mind here. So unlike with regular import or direct query models, where you can also build a report directly on top of the semantic model that you are using, here you see that we have just three available views: model view, DAX query view, and TMDL view. So in this case, we cannot build report on top of within the same file, basically using this semantic model here. So from this point onwards, this one behaves, so the process of creating semantic model is the same as with working with import and direct query models. So we can create our star schema by establishing relationships. So where is my date key column? Here it is. So I'll create relationships between the tables, between my fact online sales table and my dim date table. Then product key, here it is. Let's find it here. So product key. And finally, let's establish the one between the customer key columns. So customer key goes to customer key. And we have now our star schema model built as a Direct Lake semantic model on OneLake. Now, please pay attention to this label, this information here at the top, which says that all changes are automatically applied to your model in the Power BI service. And what does this mean? Let me show you quickly. So I'll go and resize this window a little bit, and then I'll also put this one just next to it so we can compare in parallel and see how these changes are reflected directly on the semantic model stored in the workspace. So let me go to workspaces and find our new semantic model. There you go. So direct lake on OneLake demo. Open data model. And you can see that now I'm in the viewing mode and changes will not be saved because I'm now managing and working with this model in Power BI Desktop. So what happens if I simply rename this table from contoso_dim customer to dim customer, and I'll rename others as well. And now I refresh this. You see that now our tables have also been renamed. Now, so that is when working with semantic model. Now what happens if I go back to a workspace and let's say I want to create a new report based on this semantic model. So I'll click on 3 dots next to direct lake on OneLake demo and choose the option to create a report. Let's create a little more space here. So basically what I wanted to do now, let's change the name also of our fact online sales table to just online sales. And you see that this change is immediately applied and propagated to the report itself. So that's what I wanted to say. Be aware that as soon as you make a change to your semantic model, this will be automatically propagated to all the reports that are live connecting to this semantic model, for better or for worse. Of course, sometimes maybe this can cause some broken reports. That's why I wanted to say be aware that when you make changes through the Power BI desktop, it's not the same as with import or direct query models where you go and explicitly hit this publish button to publish the semantic model to the workspace. In this case, all the changes you make are instantly visible and applied to the semantic model and all the downstream reports as well. So again, what we can do, we can create a new measure. In this case, I'll create just a simple measure for calculating sales amount. So it's just a sum of the sales amount from our online sales table. As soon as I do that, you see that it's literally within a second that this measure is also available now in the report itself. So let's make a little more space to our report and I'll build just a basic cluster bar chart that will show the total sales amount for each customer education. So you see that for each customer education type, we have total sales amount spent. Again, similarly to the current version of Direct Lake on SQL, you cannot create calculated columns. At least those calculated columns cannot be referred from the Direct Lake semantic model. We will talk about extending this model by adding import or direct query storage mode tables and creating basically a direct connection through the Direct Lake semantic model. But if it's a pure Direct Lake, you cannot create DAX calculated columns and DAX calculated tables except for calculation groups and field parameters, which are considered as special implicitly created DAX calculated tables. Few more things to keep in mind. So you can manage roles here and create role level security roles. So like in regular import mode model. And another good thing is that under the model and then under semantic model, you can change many things like we did previously. But the thing that you cannot change in this case is Direct Lake behavior. There is no possibility to allow fallback behavior to a direct query storage mode like it's possible in Direct Lake on SQL version. which is the old version of Direct Lake basically. In this case, it's Direct Lake only, so no SQL queries allowed, no fallback, because there is no SQL endpoint involved when working with Direct Lake on OneLake. So this Direct Lake behavior property will be grayed out, and it's by default set to automatic, and it will always behave as Direct Lake model. If I connect and create the same model with Direct Lake on SQL, I could have changed this Direct Lake behavior to be either automatic, either Direct Lake only, or Direct Query only. Okay, so one more thing that I wanted to show you is how to bring additional data. So we can combine data from multiple Fabric artifacts. So I will click on OneLake catalog, and as you can see at this moment, so as of end of April 2025, only lakehouses and warehouses are supported. Although we may expect, and it was also announced, that in the future other Fabric items will also be supported, and I wouldn't be surprised to see here, to be honest, because basically you can create delta tables from your KQL databases and Power BI semantic models by enabling this OneLake integration feature. So when you do that, when you enable this OneLake integration feature, tables from your import mode models and KQL databases will be created in OneLake as delta format. And essentially, Direct Lake in the end reads delta tables from OneLake. So I'm expecting to see at least these two also as well for SQL databases. That applies as well. So I would expect to see these items also supported in the future. In this case, let's connect to a warehouse, and I'll connect to this DBH_DP700 warehouse. And from here I can pick, for example, this my data source table. This doesn't have any connection to currently tables that I'm currently using, but this is just to show you how you can basically bring the data into a single Direct Lake on OneLake model from multiple Fabric items. Also, I can bring the data from another lakehouse. Let's go and find, for example, this OneLake data engineering, and for example pick this one, I don't know, sales. Click OK. So you can mix and match data from multiple Fabric items in a single Direct Lake semantic model, which is not the case with Direct Lake on SQL, where it's allowed to connect only to a single Fabric item, right? So you can't combine data from multiple Fabric items. In case you have a table, let's say sales table in a different lakehouse, this one was in OneLake data engineering lakehouse. In case I want to have this table in my Direct Lake on SQL model, I need to create a shortcut from my lakehouse called fundamentals_ms_fabric. I need to create a shortcut to the sales table, and then this table can be used within the semantic model. I can't combine data from multiple tables. Another thing to keep in mind, and another big difference between the Direct Lake on OneLake and Direct Lake on SQL, is that if you try to create a new solution, new Power BI solution, new Power BI semantic model from Power BI desktop, and basically I will repeat the same steps as when we started. So I'll connect to a lakehouse, fundamentals_ms fabric, and I'll try to connect the same way as I did with the new connect to OneLake. So I'll connect to a SQL endpoint. So what is going to happen? I'll first need to provide my Microsoft account for connecting. So now I'm connecting to my lakehouse through the SQL endpoint. You see that also dialog window is different. And now we are not accessing data directly from OneLake. We are accessing data through the SQL Analytics endpoint. And let's pick same tables: team customer, team date, team product, and fact online sales. And once I click load, I will be prompted if I want to use an import mode, which will basically physically import all the data from these tables into Power BI, or direct query. So I cannot create direct lake semantic model on SQL using Power BI Desktop. Once the model is created, I can connect to it from Power BI Desktop and I can live edit it, but I cannot create it from scratch like I did with Direct Lake on OneLake. Okay, so that's another big point of difference between these two. Why this new Direct Lake on OneLake can be potentially a big deal? First of all, previously we had to create so-called shallow lake houses or warehouses that were serving a sole purpose of being a blueprint for direct lake semantic models, and we were creating all these internal shortcuts to bring data from multiple lake houses. Now you can go out of the box and mix tables from multiple fabric items in a single direct lake semantic model. This is a huge benefit, and also a fact that we can use Power BI Desktop tool for creating and managing direct lake models, the same as we were doing for years with import and direct query. Now, the fair question would be what the future brings for direct lake mode in general in Microsoft Fabric, and will we see this SQL flavor slowly dying and becoming obsolete now that we have this new direct lake on OneLake? Honestly, I don't know the answer, but my personal opinion is I don't see why someone would go this SQL route starting from today. The only viable reason would be to have a direct query fallback as a plan B in case direct lake doesn't work. Because don't forget, there is no possibility to use direct query in direct lake on OneLake. Performance wise, I would also assume, that's just an assumption at this moment, that OneLake version will provide a better experience in terms of synchronization between OneLake and semantic model data, because there is no man in the middle, there is no SQL Analytics endpoint anymore. Sometimes there is a lag, and sometimes you need to wait between the data stored in a lake house and exposed through the SQL Analytics endpoint is visible. So sometimes data is different between these two. There is a lag in synchronization. Now without SQL Analytics endpoint and with Power BI Direct Lake semantic model directly accessing data in OneLake, I would expect to see the latest data that is available in OneLake to be also part of Direct Lake semantic model. And additionally, Microsoft announced recently a new concept of handling security in Microsoft Fabric, which is called OneLake Security. With this new option, basically the idea is to set security rules and all the permissions directly on the table, on the Delta table stored in OneLake, and then these permissions will be applied and propagated across all the different engines and workloads in Microsoft Fabric. So in this case, the main beneficiary of this new approach in terms of Power BI, of course, will be these new Direct Lake semantic models on OneLake, because right now we need to handle permissions through the SQL Analytics endpoint. There is a setting called read all SQL endpoint data. Now with this new approach, you don't need to handle this permission anymore. So to wrap up, here are the key differences between the Direct Lake on OneLake versus Direct Lake on SQL. First of all, with Direct Lake on OneLake, you can combine data from multiple fabric items. Right now, only lake houses and warehouses are supported, but we can expect other fabric items in the future as well. Whereas in Direct Lake on SQL, you can use tables only from a single fabric item, a lake house or a warehouse. Next thing, if you need to rely on direct query fallback, then you should go with Direct Lake on SQL version, because in Direct Lake on OneLake, the new version, this feature is not supported. So you cannot use direct query at all. And that also brings us to another important consideration. If your semantic models are relying on T-SQL views, so views that are created in Microsoft Fabric, then you cannot use Direct Lake on OneLake, because views will not be exposed at all. Whereas with the existing one, with Direct Lake on SQL, views can be used, but please bear in mind that in those scenarios, your queries, your direct lake queries will automatically fall back to direct query storage mode. Regarding the authoring tool for semantic models and reports, with new direct lake on OneLake, we are using good old Power BI desktop to create and to manage Power BI semantic models, whereas with direct lake on SQL, you can't create a new semantic model from scratch using Power BI desktop, so you need to create your semantic model in Fabric web user interface, and then you can connect with Power BI desktop to the existing direct lake model and make some changes in real time. And finally, regarding the permission model, with direct lake on OneLake, permissions are set on each different Fabric item that you plan to use or that you are using in direct lake semantic model, whereas in the direct lake on SQL, the old one, permissions are handled through the SQL Analytics endpoint. Hope this was useful, and if you like this video, please make sure to click this like button down below. Also, make sure to subscribe to Data Mozart YouTube channel. I'll be sharing more Microsoft Fabric and Power BI related videos soon, so it would be great to stay in touch.